again, this is Miss Jackson. Technology is totally unexpected, especially with the weather being that it is. So hopefully you were able to get part one of this. This is again another example pertaining to the actual fractions. So you may notice that I have written down that all fractions have different denominators, so they should be alike, meaning they should have the like denominators, which is the bottom number. So in this case, we have to find the least common denominator. I'm looking at my two smaller denominators, so 3 times 2 is 6. And remember earlier when I said I don't like fractions? So I'm going to multiply everything by that least common denominator, which is 6, to get rid of the fractions. So again, the entire problem, which is within the parentheses, is multiplied by 6. Well, when I simplify that, I know that 3 can go into 6 2 times. 2 times n gave me the 2. 2 can give the 6 3 times. 3 times 1 gave me the 3. And then the 6's right here eliminate each other, so I just brought down the 5. Now we're going to combine like terms by adding 3 to both sides. So when I add 3 to both sides of this, the 3's cancel each out on the left-hand side. 5 plus 3 gives you 8. Now I'm going to isolate the variable. So divide both sides by 2, and 8 divided by 2 gives you 4. So once again, feel free to stop, fast forward, or rewind with this, because hopefully we won't have any more technical difficulties. Yet again, more fractions. So this time around, we still got to find our least common denominator. So when I multiply 4 times 3, that gives me 12, and I'm getting the denominators from the bottom part of the fractions. So my A's kind of look like 9, so my apology. What I'm going to do now is multiply everything by 12, because 4 times 3 is by 12, so that's your least common denominator. Once we do the distributive property, we're going to simplify. So I know 4 can go into 12 3 times. 3 times 8 gives you 3a. 3 times 12 gives you the 36, so I brought down 36. Bring down your equal sign. 3 can go into 12 4 times. 4 times 8 gives you 4a. And 12 times 5 gives you 60. Your next step is combining your like terms. So notice how I underline the ones that have your a's, and I circled the ones that are your constants. Be mindful that it does not matter what order you choose to do this, just make sure you are consistent with it. So what I'm choosing to do is add 36 to both sides, because I like my numbers positive. Think about it like you add money to your bank account, and we always like money. So they cancel each other out on the left-hand side. 60 plus 36 gave you the 96. Bring down your 4a and your 3a. Notice how the 3 is already completely by itself, so we're going to subtract 4a from both sides. Now, it is okay to have a negative variable. That's fine. So notice how I brought down my 96. Now I'm going to divide both sides by negative 1. A negative divided by a positive still gives you a negative, and a positive divided by negative still gives you a negative. So your final answer is negative 96. So, woohoo! Let's make it even more complicated with some more fractions. So here goes another example. So once again, we don't like fractions. Well, at least I don't. I want to eliminate the fractions because it's a little bit easier to solve an equation when you don't have the denominators, just whole numbers. So notice how your denominator for both of these fractions are 2. So I'm going to multiply everything by 2. So I call it get rid of the fractions. The proper way of saying that is that all of them have a least common denominator of 2. So once again, multiply everything by 2. This is where you get into the distributive property. So here we go. 2 times 2x gives you 4x. 2 times 7 gives you 14. These 2's cancel each other out, so I just bring down the 6x minus 5. That's just like me doing an imaginary 1. Same thing with these 2's. These 2's also cancel each other out, so I bring down the negative 1. So we just completed the distributive property. Your next one, you're going to try to simplify. So first I'm going to identify what my like terms are. So I circled the ones with the variables and I underlined the ones without the variables. Remember, the ones without the variables are called constants. Combining your like terms now, and I said oops right here because I made a mistake, so my bad, y'all. So 4 plus 6 gives you 10, bring down the x. 14 minus 5 is 9, and then bring down the negative 1. Again, I said oops because I made a mistake, so the actual equation itself is just 10x plus 9 equals negative 1. Now we're going to combine our like terms still. Subtract 9 from both sides of the equation, because 9 and 1 are both the numbers that do not have the variable. The opposite of addition is subtraction. So once I did that, I now have 10x equals negative 10. Divide both sides by 10, because that's what's attached to your x. And your final answer is negative 1. So remember, when you divide or multiply unlike terms, your answer is going to be negative. When they're like terms, the answer is going to be positive. But wait, there's more dealing with fractions, y'all. Check this one out. So now we still have a fraction. Notice how there's still different denominators. So we're going to find our least common denominator by multiplying 2 and 3. So 2 times 3 gives you 6. So that's where I got it from. Now multiply everything by 6. Now the reason why we want to do the 6 is because we don't like fractions. And that's not the proper way of saying that. I need to stop saying I don't like fractions, even though that's true. The correct way of saying that, we want to make everything whole numbers or integers because it's easier to solve. So now, using distributive property, I'm going to simplify this. So 2 can go into 6 3 times. 3 times 1 is 3. 3 can go into 6 2 times. 2 times 2 is 4. And then 6 times 7 gives you 42. So let me go over there real quick again. I'm using division. So 6 divided by 2 gives me 3. 3 times 1 is 3. Bring down your equal sign. 6 divided by 3 is 2. 2 times 2 gives you 4. And then 6 times 7 gives you 42. Still going to simplify and combine like terms. So 3n is already isolated, so I'm going to subtract the 4 from both sides. The reason why I'm subtracting it is assumed that this is a positive 4 because there's no negative sign in front of it. So 3 minus 4 gives you negative 1n. Bring down the minus 42, aka negative 42. Isolate the variable. The variable is n. Notice how 1 is attached to the n. So you're going to divide everything by that negative 1. 2 negatives give you a positive, so your final answer is positive 42. So yay! So hopefully you're keeping up with me so far. Now these next 2 examples I find rather easy, especially if I'm using my calculator. Hopefully you realize by now that the opposite of addition is subtraction, the opposite of multiplication is division, the opposite of subtraction is addition, and the opposite of division is multiplication. So if you're using your calculators, we know that we're going to be subtracting numbers right here. But before we do this, we got to make sure we know what we're subtracting if that's the case. But right here, I said combine in like terms then divide. But there's an invisible 1 right here. So when I combine my like terms, 1 plus 1.2 gives you 1.2n. Because notice how both of these have the variable n. Once I combine them, I have 1.2n, bring down my 72. Now I divide. So 72 divided by 1.2 gives you 60. Now this one is a slight bit different. Notice how your variables are on opposite side of the equal sign versus this one. My ends were on both the same side. But when they're on opposite sides, we have to do opposite operation. So remember, this is an invisible 1. We're going to subtract 0.25 from both sides like I did right here. Well, hopefully we know how to do that because that reminds me of money. So I got $1 and I took away 25 cents. I'm left with the 0.75 is in the 12. So now, whenever we see they're attached like that, that means it's going to be division. So divide both sides by the 0.75, you should have gotten 16. Now again, I know I went kind of fast on that one because those are the same steps we did for the first 10 examples with the exception of the fraction. Now here goes one. Hopefully you can read my handwriting. This is one of the ones that you asked when we were trying to do our virtual lecture earlier today. So it says, read carefully. Find the discount sale price for a $76 item that's on sale 35% off. I said that totally wrong. So my apologies, I'm reading kind of fast. Find the discount sale price of a $76 item that's on sale for 35% off. Well, when I see the word sale and off, I know it has to be smaller than 76, so that means subtraction. So hopefully you can read the little green writing. So that sale and off indicates subtraction of 0.35. Now, where am I getting that 0.35 from? Well, that 0.35 is changing that percent to a decimal. So I moved it 2 places, or your imaginary decimal, 2 places to the left. So here it is, 1, 2. I'm going to multiply 0.35 now times my amount, which was 76. So 0.35 times 76 gave me $26.60, not 60. So it's an imaginary zero. So here's the difference between 6 and 60. That is B06 and that is B60. And going back to what we stated earlier, if it's off, we know we're going to subtract. So now we got $76 minus 26.6. That gave me $49.40. Now your calculator may not necessarily have that zero right here because it's considered a placeholder, but in terms of money, we need to make sure that we're doing it. Another example that we tried to do in class was pertaining to this right here. Though we don't have numbers given to us, it is asking us to solve in terms of R. So we have a variable and symbol and no numbers. So let's figure out how to solve for R. Given to you, you have the equation C equals 2 pi R. That's the circumference for a circle. So notice how 2 pi is attached to the R, so that means multiplication. Remember, when we're trying to solve for a variable, we do opposite of that. So the opposite of multiplication is division. So right here, I'm going to literally divide everything by 2 pi, because remember, I'm trying to solve for R. Well, these two eliminate, so I'm gone. They're by. But now I'm left with 6 over 2 pi. Bring down the R. So your answer is literally what you see. Write what you see. So you see C over 2 pi. Don't worry about the division sign because we're going to incorporate the fraction. And remember, they mean the exact same thing. Here's another one we tried to do in class. Very similar. We have a formula provided for us, but it wants to do it in terms, to solve for one term in terms of another one. I know that kind of sounds backwards, but that's what it's doing. So notice how we're solving for C. Well, the first thing I want to do is subtract 32 from both sides. So that's what I did right here. So that's me isolating the variable. Because now I should have F minus 32 equals 9/5 C. Well, you may remember us earlier saying that we can't divide fractions, but we can take the reciprocal. So the reciprocal means that I'm going to flip 9 over 5 and multiply by everything that I see. So what I see is F minus 32, so that's what the 5/9 come from. Remember, 5/9 is 9 over 5 flip, so this 5 cancels out that 5, that 9 cancels that 9 out. So now you're left with 5/9 times F minus 32 equals 6. Make sure you write this down because this particular problem and formula we will see later on in another example. Next, we have an inequality. So inequality is another way of saying not equal to. So this will be the ideal time for you to pause the video and write these down. So in regards to the inequalities, you have your less than, your equal to, greater than, and greater than equal to. Notice how your less than or equal to, your greater than or equal to's have half of an equal sign to them. The other thing you need to pay attention to, notice how the less than and less than or equal to are pointing, not the open part, but the pointing part are pointing to the left. So imagine if you had a number line and everything to the left of 0, that means it's all negative. And since there are so many numbers that could be less than 0, we're going to say that's negative infinity. When it doesn't have the equal sign, you're going to use parentheses. When it does have half the equal sign, use brackets. Now pay attention to the greater than and the greater than or equal to. They're pointing, not open, but pointing to the right. So if you're on a number line, all the numbers that are to the right of 0 keep getting bigger and bigger and bigger, hence positive 0. Once again, if it doesn't have the equal sign, you're going to use parentheses, and if it does have it, you're going to use brackets. So let's solve this inequality now. I can already tell you that I know that if I use it on a number line, I'm going to shade right, and then I'm going to use parentheses. There you go, right there. So let's figure this out. First thing we want to do is get the x completely by itself by combining our like terms. So the opposite of a subtraction is addition. So the 5 and the 2 are both like terms because neither one of them have a variable. So now I have negative 2 plus 5, which gives me 3. Now I have x is greater than 3. So when I'm shading on the number line, hopefully y'all can see that little scribble scrabble. I'm using my parentheses at 3, and I'm shading everything to the right because it's pointing to the right. In regards to interval notation, which is this right here, so ladies, gents, individuals, pay attention to this one. Because it's greater than, the 3 is going to go on the left-hand side, and positive infinity goes on the right. The reason why we're using infinity, because it keeps going and going and going and going. Hence the number line. Here's another example dealing with an inequality. Looking at the inequality, I know that I'm going to shade to the left because it's pointing to the left. Next step, combine your like terms by subtracting 1 from both sides. So the 1's cancel out right here. 4 minus 1 gives you 3. So boom, bam, pow, there we go. Now I'm going to isolate the variable by dividing both sides by 3. So we know that 3 divided by 3 gives us 1. We brought down our x, and we brought down the inequality. I know that I'm going to shade to the left because it's pointing to the left. So on the number line, you're going to have a bracket at 1, a parentheses at 1, shade to the left. Interval notation, you see how it keeps going and going and going in the negative direction? So that'd be a negative infinity, comma 1. So be careful when you're doing that interval notation. We got one more example in regards to the inequalities. In fact, we have several. So check this one out. Notice how you have inequalities or variables on both sides. So this inequality is going to be slightly different. Now you also know you're going to shade right and use a bracket. So hopefully you wrote those notes down from the previous problem. I think that was number 15. Let's combine our like terms, yeah. So here we go. So we have 3x plus 6, and then we have 2x plus 9. I like my numbers bigger because I'm always thinking about putting money in my account, hence deposit, not a withdrawal. So we're going to get rid of the 6 because the opposite of an addition is subtraction. Now I have 3x is greater than or equal to 2x plus 3. Combine your like terms still with 3x and the 2x. So subtract 2x from both sides. 3 minus 2 gives you the 1x is greater than or equal to 3. This is an unnecessary step right here, but I always do it because I'm more of a visual learner. So when I do the 1's right here, I know that my 1's cancel out right here. So bring down my x, bring down my greater than or equal to. 3 divided by 1 is 3. So we have two things to do now. Number line shading and interval notation. So here goes your number line right here with the bracket. It's shaded to the right, and here's your interval notation. Remember, it keeps going and going and going and going and going and going and going. So that's what the infinity is for. Here's yet another inequality. So notice how I wrote down distributive property. That means whatever is on the outside of each set of parentheses, multiply it by each term on the inside. That's very important. I also know that I'm going to be shading to the left and have a bracket because I'm looking at my inequality. So let's do the distributive property first. So now I got 8x minus 24 is less than or equal to negative 4 minus 4. Combining your like terms, I'm going to add 4 to both sides. So these 4's are gone. So now I got negative 24 plus 4. Now I kind of switched it up just a little bit because you remember earlier I said I like positive numbers. Well, you can always switch them up as long as you're being consistent with it. So this time I did switch it up. I got a negative number. The same thing is going to be applied when I combine my 8's. So I subtracted 8 from both sides. So now I got negative 20 is less than or equal to negative 12x. Divide both sides by negative 12. So let me pull this up and start like hiding it from you. Because here's where it gets a little bit complicated. Hopefully you can see where the negative 12x came from right here. Because that's negative 4 plus negative 8. That's the same thing as saying negative 4 minus 8. What you probably don't see is, where in the world did I get 5 over 3 from? Well, once I eliminate these 12s, I'm just left with x. But I also know that 2 negatives give me a positive, so now I see 20 over 12. I can simplify that by 4 because I know 4 can go on both of these numbers. But wait a minute, there's more. I had to flip this symbol because that x also was negative because of that 12. So not only did I have to simplify it by 4, so 20 divided by 4 gives me 5, 12 divided by 4 gives me 3. I had to flip that symbol because that x was initially negative. If I rewrite it, notice how it's pointing to the x. I just rewrote it as like a mirror image. So I'm reading it from left to right. My symbol is still pointing to the x. So now we know that x is less than or equal to 5/3. In regards to the number line, it's going to be a bracket because you got half of that equal sign. I also know that I'm going to shade to the left because it's pointing to the left. In regards to your interval notation, because it keeps going and going and going in the negative direction, you're going to have negative infinity. Infinity can never be bounded, meaning it never ends, so you will always use a parentheses, and then your bracket will only be used for the 5/3. And here are some more fractions, yeah. So once again, we're going to find the least common denominator. So 4 times 3 gives you 12. Multiply everything by that 12. So let's figure out how we're going to do this. So I know 12 divided by 4 gives me 3. 3 times 1 is 3x. So bring down that 3x or the x. 12 divided by 3 is 4. 4 times 4 gives me 16. Bring down the x. Bring down your less than. Bring down the minus. And 12 times 13 is 156. Yay! Now we're going to combine our like terms right here. Notice how your x's are on both on the same side. So 3 minus 16 gives you negative 13x less than negative 156. We're going to isolate our variable by dividing both sides by negative 13. But remember, notice from here to here. Everybody see that? It flipped because that x was what? Negative. That is a general rule. You're going to flip it when your x is negative. So now I got negative 13x greater than negative 56. Divide both sides by negative 13. I know that my final answer is x is greater than 12. But when you input it in, interval notation, in case we didn't write this down the first time, we started on inequalities. 12 comes first, and then we have infinity. Notice that you're not using brackets because it does not have an equal sign. So on the number line, you're going to have a bracketed 12 and shade to the right. Now it gets a little tricky. Now stop covering them up because some of us are fast forwarding through the video because we already understand it. 21 is considered a compound inequality because you literally see a conjunction, the word and. So yeah, we do a little grammar in there. Though they're two different inequalities, we still got to work them out together. So I'm going to solve for both inequalities. My first inequality is x plus 6 is greater than negative 2. Well, notice my inequality. I know I'm going to shade to the right. Next inequality, x plus 6 is less than positive 2. So right here, I know that it's pointing to the left, so I know I'm going to shade left. So notice how both of them are shading in opposite direction. That means somewhere on my number line, I'm going to be between something. So let's figure out what we're going to be between. The opposite of subtraction is addition. The opposite of addition is subtraction. So now we got negative 2 minus 6. So these are just again like your like signs. So you may remember in part 1 video, I said like signs, you add, unlike signs subtract. Take the sign of the greater number, then you'll be exact. So both of them are negative, I combine them. So now I got x is greater than negative 8. Right here, subtract 6 from both sides. So once again, like signs, you add, unlike signs subtract. Take the sign of the greater number, then you'll be exact. So these are unlike signs, so I'm going to subtract. And I forgot my negative right here. That's a negative 4. Boom, bam, pow. So I may have made a mistake right here, but from what I'm looking at, I just forgot my negative. So 2 minus 6 gives you negative 4. So that's a negative 4. And both of these are parentheses. Kind of looks like brackets. But this is your interval notation. It's negative 8, comma, negative 4. On the number line, shade between negative 8 and negative 4 where you got parentheses. But wait, we're not done yet. Haha. We have yet another compound inequality. But this time around, notice how your variable is in the middle. So note how the variable is in the middle. So your x is in the middle. So check it out. We have to combine our like terms by simplifying it. So if we do it on one side, we definitely have to do it on the other. So I'm adding 1 in the middle. So the opposite of addition is subtract. So subtract it from the negative 9, subtract it from that 1, subtract it from the 11. These are like terms, so you're going to combine them, but it's still going to be a negative 10. Bring down your less than sign. Bring down your 5x, and 11 minus 1 gives you 10. So far we're on the right track. Next, which I didn't write down, isolate your variable. Now what I mean by isolate your variable, divide everything now by 5 because that's what's attached to your x. So negative 10 divided by positive 5 gives you negative 2. These two 5 cancel out, so bring down your x. And then positive 10 divided by 5 gives you positive 2. So notice where the x is again. The x is between two numbers. So you may not necessarily have to do the interval notation for this, so be careful when you do it, if that makes sense. But notice how the x is in the middle, and you're going to have all of that. Here goes one that is a little bit more complicated. Did I do it right? Did I do it right? No, I skipped one. My bad. Okay, now here goes back to the one that we did earlier. Feel free to rewind. I think it was number 15. But it wants you to actually solve for the numbers provided for you, given that this is what's given to you. But you have to solve it in terms of C. So what I did was subtract 32 from both sides and then take the reciprocal. Next thing I did was substitute. And what I mean by substitute, called plug and shove. Plug those numbers in. So given to you, you had negative 14 degrees Fahrenheit and positive 14 Fahrenheit. The problem is asking for the C, not for Fahrenheit. So I substitute those numbers in. So for the first one, I got negative 13. So negative 13 minus 32 gives you negative 45. 9 can go into 45 5 times, so that's negative 5 times 5, that's negative 25. 14 minus 32 gives you negative 18, so 9 can go into 18 2 times, that's a negative 2. 5 times negative 2 gives you negative 10. So your two answers now are negative 25 and negative 10. Here's the next to the last one. So now we're dealing with absolute value. Hopefully you remember from Module 1 homework that absolute value means that it's how far our unit is from 0. So in this example, we're not looking at what's on the inside. We're looking at what's on the outside. So we're looking at 6 and negative 6. So I rewrite it. So I got 2x minus 2 equals negative 6. And then I got 2x minus 2 equals positive 6. Remember, absolute value is dealing how far it's from 0. Since 0 generally is in the middle of a number line, we're going 6 units to the left and 6 units to the right. 6 units to the left is a negative. 6 units to the right is positive. As we've done for the first 3 examples, for solving for x, we're going to do the opposite operation. So the opposite of addition is subtraction. The opposite of subtraction is addition. So in this case, we're going to add to both sides. So these 2's cancel out. Bring down your 2x. Negative 6 plus 2 is negative 4. Divide both sides by positive 2. So my x is negative 2. So don't forget your signs about your negative and positive. Go on to the positive side. Still add 2 to both sides. So these 2's cancel out. 6 plus 2 is positive 8. So now we got 2x equals 8. Divide both sides by 2. 8 divided by 2 gives you 4. So your answer is negative 2 and positive 4. So hip hip hooray. Oh, hey, oh. And our last one. Still dealing with inequalities and absolute value. So this is going to take a minute to explain. For starters, I know it's going to be a greater than or equal to. I'm looking at that. Look at that. It's going to be kind of difficult to shade this because it's going to be going in opposite directions. Because remember, absolute value is going to be dealing with both positive and negative. So let's get rid of this 4 first. Now what I mean by get rid of the 4, I want this absolute value in the line completely by itself. So I'm going to add 4 to both sides. That gives me 7. So now I'm going to rewrite this. Instead of using the inequality, I'm going to use the equal sign because it's just a little bit easier to understand. So now I got x plus 7 equals 7. And then I got x plus 7 equals negative 7. Now why am I using a positive 7 and negative 7? Remember, absolute value. So on this part, x is greater than or equal to 0. So let me rewrite that so it can be consistent to what we have. Oops, I turned the page. Okay. And the same for the right hand side. Negative 7 plus negative 7, or negative 7 minus 7 gives 14. So now we got So I'm just trying to be consistent with the actual symbol itself instead of the equal sign. Unlike an equation, an inequality does not have just one answer. It has multiple answers. So for example, an equation, x equals whatever number it was, versus an inequality, it either can be less than, greater than, or equal to, greater than, or greater than, or equal to. So in this case, we know that we have the negative 14. So I didn't flip my sign, so that's my fault. So therefore it's got x is anything smaller than negative 14. And I still didn't write it right. I'm looking at one of these. That's negative 14 right here. I wrote this way too fast, so my apologies, y'all. But you can see where I'm getting the numbers from at least. So let me go back. For this one, since we're doing the positive end, that means x is greater than or equal to, or x is bigger than any number that's bigger than 0. Then for the negative side, that means x is smaller than anything smaller than negative 14. Notice how your symbols are going in different directions. So when I write this in interval notation, negative comes first because we're reading this from left to right in regards to a number line. So we got negative infinity, comma, negative 14, then the bracket. Why do we have a bracket? Go back up here. It has half the equal sign. This little symbol right here means union. Now the reason why it means union, think about what we're doing. We're doing a compound inequality. So it has to have both answers because we got two different inequalities going on. Bracket again, because we have that symbol, half of the equal sign, then 0 and positive infinity. So if I had to draw this on a number line, we know that we're going to have a bracket at negative 14, and it's going to be shaded to the left because I got everything to negative infinity. Then I'm going to have a bracket at 0, and then everything is going to be shaded to the right because I got positive infinity. So that particular problem, you may have to do more than once, but be mindful that you will have MathWay as a resource. So ladies and gents, thank you so much for your patience and understanding in regards to our technology. I will email you and text you shortly about where to find your answers. So thank you guys.